Hey guys, welcome to Mrs. Stroh's first attempt at making a video PowerPoint lesson for you to view on Net Classroom. We're starting with the next lesson in Chapter 6. We've started quadrilaterals. You guys know all about the interior angles of polygons, the exterior angles of polygons, and now we're just going to focus in on quadrilaterals themselves. And the first kind of quadrilateral we're going to talk about, kind of one of the kids of quadrilaterals is parallelograms. We're going to look at what are their properties and what are ways that we can test and see if a quadrilateral is a parallelogram or not. Alright, so if you were to see the definition of a parallelogram, you don't necessarily have to put this in your vocab sheets, but if you were to, here's what we would put. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. And we kind of hear that just from its name, parallelogram. Okay, and we know it's got four sides because it's a quadrilateral. Facts and characteristics. This is what we're really digging into with parallelograms. In any parallelogram, the opposite sides are going to be congruent. The opposite angles in the parallelogram are also going to be congruent. And the consecutive angles, those are the angles that are right in a line with each other along the same side. Okay, consecutive side, same side. Those angles are supplementary, add up to 180. And then symbol or notation for a quadrilateral or a parallelogram, we use this little parallelogram shape. You put that in front of it, its names like parallelogram ABCD, just like we wrote triangles, but we use the parallelogram. Okay, so here's a couple of examples showing some of these properties of parallelograms. Here we've got opposite sides parallel in the first example, and that's named. You see its name at the bottom, parallelogram ABCD. Notice that it's named in order around the shape. We don't jump across the shape as we name it. And then the second example, we've got another parallelogram, JKLM. We know it's a parallelogram because its opposite sides are congruent. That's a condition for a parallelogram. Alright, and just to re-emphasize again, let's mark all these different properties of parallelograms here, okay? So let's say this is, we know it's parallelogram FGHJ. We name it again by going around the verses. We know opposite sides are congruent, so FG is congruent to JH, and FJ is congruent to GH. Okay, what else do we know? Well, opposite angles are congruent. So angle F and angle H are congruent angles. Angle J is congruent to angle G. Those are opposite angles. They're opposite one another in the quadrilateral. Consecutive angles are going to be supplementary. So if I said angle F is 75 degrees, you guys know angle J or angle G, either one, is going to be supplementary to that. It makes 180. So we need to add 105 degrees on to either corner right next to angle F. And of course, if angle F is 75 degrees, so is angle H. Alright, so there's just a closer look at parallelograms. Okay, some real-life examples for you to kind of get your head around these properties. In a basketball goal, we've got a parallelogram ABCD formed by the poles supporting the backboard. Suppose the measure of angle A is 55 degrees. So we know that angle A is 55 degrees right here. We know the length of section AB. Okay, this section here, that's 2.5 feet. And BC, the other end of the parallelogram, the vertical end, if you will, is 1 foot. Okay, I should get my units in there, huh? Feet, all the way around. Okay, we want to find each measure. So the first one, what's the length of DC going to be? This one right here. Since it's a parallelogram, we know opposite sides are congruent. So DC is going to be the same thing as AB, 2.5 5 feet. Okay, easy enough to see. What else do we want to find? Angle B. Okay, so far we know angle A, that was 55 degrees. Angle B is not opposite angle A, it's consecutive to angle A, so it's supplementary. So we just need to figure out 180 minus 55 to get angle B. 180 minus 55 is 25. 125, sorry, 125 degrees for angle B, which makes those consecutive angles supplementary and keeping with those properties of parallelograms. Okay? Alright, your turn. Find the measure of angle C. Find the measure of angle C. Got it? If you said angle C is 55 degrees, you are correct. Opposite angles are congruent, that's opposite angle A. Alright, we can do the same thing here. If you've seen these stretchy mirrors, I think you can get them at IKEA, sometimes in hotels. There's another parallelogram here. You can find the missing measures knowing only one angle and knowing that it's a parallelogram. Angle L is opposite angle J, so those are going to be congruent. Angle M is next to angle J, consecutive with it. They're supplementary, so you subtract from 180 to find angle M. I'll let you guys try those on your own for some additional practice. Alright, some more properties of parallelograms that we can use to solve for parts of parallelograms. The diagonals, that's connecting corners that are opposite each other. Okay, those diagonals bisect each other. They cut each other in half. So AC is bisecting DB. Those are equal to each other. And DB bisects diagonal AC. So those would be congruent to each other. Okay. Also, another fun fact, one diagonal by itself cuts the parallelogram into two congruent triangles. But we're really going to focus on this first part. The diagonals bisect each other. This here. Alright, let's put together everything we know about parallelograms and solve for missing parts. Find the value of each variable in a given parallelogram. Okay, let's start with x. X has to do with angles. And we've got 4x here and 2x minus 6 here for this angle. Now, those are not opposite angles, they're consecutive angles. So we know that they are supplementary. We know that 4x plus 2x minus 6 altogether has to equal 180. Alright, so we've got x is on the same side here. Let's combine those like terms. 6x minus 6 equals 180. And end of solving the equation. Add 6 to both sides. Divide by 6 on both sides to get x equals 30. And of course you can double check by plugging that in to both angles, making sure they add up to 180. Okay? There's x. Now let's take a look at y. Y has to do with sides of the parallelogram. And we know that opposite sides are congruent, so y plus 8 equals 5y. Opposite sides are congruent, so those two sides have to be equal. Get all the y's together on the same side. 8 equals 4y. Real quick, divide by 4, and we know that y equals 2. And again, you could plug it into both sides and make sure they're actually equal to each other. 10 is equal to 10. Okay? Alright, now let's find z. This has to do with diagonals in a parallelogram. Here's that property we looked at just a couple minutes ago. Each of the diagonals bisects each other, so this half of the diagonal is equal to this half, and this half of this diagonal is equal to this half. The z's have to be at the same diagonal, so we know that 3z minus 4 is equal to z plus 5. Diagonals bisect each other, so they're cut into 2 equal parts. Alright, let's solve for z. Combine all our like terms. And isolate that variable. Z equals 5, divide both sides by 2, and z equals 5 over 2, or 2.5. Okay? Diagonals of a parallelogram bisect each other, and that's how we can solve for missing parts, using that property. Alright, here's a big one where we put them all together again. We've got 3 variables in there missing. X has to do with a side, and we've got its opposite side, so you know opposite sides are equal, congruent. 5x has to equal 27. Divide and solve for x. Going to get another decimal. 5.4 or 5 2/5. Okay. So quick, easy to solve for x there. What about y? Y, kind of hard to tell from the picture, but it has to do with the diagonals again. The two y expressions have to do each with their own half of this diagonal. And we know that's cut in half by itself. So 2y minus 5 has to equal y plus 4. Alright, you guys take a turn. Go ahead and solve for y. Got it? You got y equals 9. You are correct. Finally, let's find z. Z has to do with angles here. We've got angle QST is 3z. We also know this angle up here and angle 33 right here. Let me try that 95 again. Sorry guys, learning curve with this new technology. Okay, we know QRST is a parallelogram. Key part of that word being parallel. We always know in any parallelogram, opposite sides are parallel to each other. And where there are parallel lines cut by transversals, we have special angle pairs. The key angle pair here is the 33 and 3z. Those are alternate interior angles, as you may remember. So we know that 3z has to be equal to 33 degrees. Alternate interior angles are congruent, so these have to be equal. Real quick, divide both sides by 3, and z equals 11. And there we go. We have solved for all of the missing variables using properties of parallelograms. You could also extend this into coordinate geometry, not just any parallelogram in space, but parallelograms on the coordinate plane. If you know the vertices of um, the parallelogram and know where to graph those on your graph, you can find any missing parts again. Alright, we want to determine the coordinates of the intersection of the diagonal. So this point right here, marked in the middle of our graph. Where do the diagonals intersect? Well, what do we know about the diagonals of a parallelogram? They bisect each other. They cut each other in half, which means the intersection is going to be at the midpoint of each diagonal. Midpoint of each diagonal. So all we have to do is pull out our handy midpoint formula. Remember that is taking the average of the coordinates x1 plus x2 divided by 2 over y1 plus y2 divided by 2. Okay? Our x1, y1, and x2, y2. It really doesn't matter which diagonal we go with, but we do have to pick coordinates that are on the same diagonal. So we either pick f and h, or we can pick j and g. I'm going to go with f and h since those are the first ones we come to. Okay, so we're going to use f as our x1, y1, excuse me, 1, and h is our x2, y2. Alright, so let's plug them in. x1 plus y1, x1 plus x2 over 2 gives us our new x coordinate, and y1 plus y2 over 2 gives us our new y coordinate. So we've got negative 2 plus 2, or 0, over 2 for x. 4 plus negative 3, that's the same thing as subtracting, so 1 over 2. And finish simplifying. 0 divided by 2 is just 0. 1 over 2 we can keep 1/2, or if you want to write it as 0.5, that's fine too. But there is our intersection of the diagonals. And if you look closely at the graph, you can see x is definitely 0. We're on the y-axis, and it's up just a little bit above the origin. Each block there is 2 units. So a little bit above, about a quarter of the way up, is going to be 1/2. Now, each of the quadrilateral properties of parallelograms can also be used as tests for whether a quadrilateral is a parallelogram or not. Okay, so let's say you only know that a shape is a quadrilateral. You don't know if it's a parallelogram or not. Well, you can use those properties to check if it is a parallelogram or not. So if you know or can determine that both pairs of opposite sides are congruent, that's enough to say you've got a parallelogram. Or if you know both pairs of opposite angles are congruent, that's enough to say you've got a parallelogram. So on and so forth. The other couple checks, of course, you know that diagonals bisect each other, so if you see that happening in a quadrilateral, you can say it's a parallelogram. This last one, let me kind of point this one out. This one's a little bit tricky. It's kind of combining the rest of the definition of a parallelogram. Opposite sides that are both parallel. Okay, so one pair of sides you know is parallel, because we know both pairs of opposite sides in a parallelogram have to be parallel. But if you know one pair is parallel and that same pair is also congruent, then that's enough to say you've got a parallelogram. And what that last scenario covers is opposite sides being parallel and consecutive angles being supplementary. And that's kind of covered in that last check. Okay, so let's real quick see if we can go the other way. We've got the conditions for parallelograms to see if a quadrilateral is a parallelogram or not. Alright, determine whether the quadrilateral is a parallelogram and justify your answer. So right away, when we look at the sides, We've got 14 inches here and 14 inches here. So there's one side, one pair of opposite sides that are congruent. Okay, if we go back, oh, I can't go back, that's okay. One pair of opposite sides congruent. If the other pair of opposite sides is congruent, then we can say it's a parallelogram. But we don't have enough information to prove that, so we can't go with that route. The other check for a parallelogram that involves a pair of sides is if that pair of sides is congruent and parallel. So if we have a way to show that these two sides are also parallel, we're golden. And the only other thing we know are these angles here. We got 100 degrees and 80 degrees. Those are supplementary angles, and they're consecutive angles or same side interior angles. And from way back in chapter 3, we know that if same side interior angles are supplementary, then we're dealing with parallel lines cut by a transversal. So not only is FG congruent to JH, but now we have shown that FG is parallel to JH because angle G and angle H are supplementary. So we've got a pair of opposite sides that are parallel to each other and congruent to each other. So FGJH is a parallelogram. This one checks out. Let's try another one. What do you think? Parallelogram or not? All we know are the sides. There's one pair of opposite sides congruent. There's two pairs of opposite sides congruent. That is a parallelogram. Now, how do you think about this when you opened it? One pair of opposite sides is congruent, and one pair of opposite angles is congruent. Our conditions for parallelograms say we have to have either both sides of the parallelogram, pairs of opposite sides congruent. So we would have to know these are congruent and these are congruent. Or, both pairs of opposite angles are congruent. So we would need to know this and this. What we've got is a mixture of those. So there is not enough info here to prove this is a parallelogram. We just keep it at quadrilateral. Alright. Instead of justifying now we want to solve for missing parts so that it is a parallelogram. So FK is 3x minus 1 out of the diagonal. KG is 4y plus 3. JK is 6y minus 2. And KH is 2x plus 3. At the plus. Alright, find x and y so that the quadrilateral is a parallelogram. So, since these have to do with the diagonals, if this is going to be a parallelogram, the diagonals have to bisect each other, which means we need 3x minus 1 to be equal to 2x plus 3. Right? Diagonals have to bisect each other, so these two have to be congruent to each other. And here we go, we just solve for x. Subtract 2x from both sides, and now we've got x minus 1 equals 3. Add 1 on to both sides, and already we found x equals 4. Quick two-step equation. Okay? Y, we have to find x and y. This isn't enough by itself to be making this a parallelogram, so we also have to find y. Same scenario, we need both the diagonals to bisect each other. So we need 6y minus 2 to equal 4y plus 3. Subtract 4y from both sides. We got 2y minus 2 equals 3. Add 2 onto both sides, we got 2y equals 5. We've seen this earlier today already. Divide both sides by 2 and you get y equals 2.5. Alright, these have to be the values of x and y in order for FGHJ to be a parallelogram. These numbers will make it so that the diagonals are bisecting each other, making it a parallelogram. Okay, and we did all that by starting out and writing an equation. Okay, that's using properties of parallelograms to get that equation set up and then solving for your missing variables. Alright, you guys try this one. Find x and y so that the quadrilateral is a parallelogram. Now you're dealing with angles, so you know that opposite angles have to be congruent. Alright, start again by writing an equation, solving for x and y. Alright, let's see how you did. X is equal to 7x equals 56, so divide 56 by 7, we get 8. 4y plus 4 has to equal 5y minus 26, which means y must be equal to 30. Hope you did alright with that. Let's try one more. Find x and y so that the quadrilateral is a parallelogram. Start by writing your equations. And this time I'm going to have you identify for yourself what property of parallelograms or what test for parallelograms are you using here. Those 4 checks are opposite sides, both pairs are congruent, or both pairs of opposite angles are congruent, or maybe you're looking at the diagonals bisecting each other, or one pair of opposite sides being parallel and congruent on the same pair of sides. Which one of those checks are you using here to set up your equations and solve for x and y? Alright, time to check. X equals 3, and for y we should have 7. And the way that we know how to set up our equations for x and y, opposite sides should be congruent. 3x plus 4 has to equal 5x minus 2. 4y minus 9 has to equal 2y plus 5 in order for this to be a parallelogram. Okay? Alright. There's your introduction to properties of parallelograms and how we can use them to test if a quadrilateral is a parallelogram or not. Tomorrow in class, we can review any questions you have from these examples. We'll extend it a little bit to verifying if the quadrilateral is a parallelogram on the graph, and then you guys will do some practice and application problems in class. Alright, hope this has been fun and helpful to you, a little more interactive than just scrolling through a PowerPoint. Let me know how it went for you in class tomorrow. Thanks, guys.